Hey, I'm Jan Metzner. I'm a specialist solutions architect for manufacturing here at AWS.
Hi, I'm Ivan and I'm a senior solutions architect with AWS. Why am I standing here? Because I've been working with manufacturers for half a decade and I've been always trying to help them build the coolest solution possible you can make work in the cloud. And that passion I would like to bring into this conversation and try to have a little bit of a spark also seen throughout the things we've built and we want to talk about with you today. So what is the reason for me standing here? I want to talk to you about bringing people together and bringing technology together. When I say bringing people together, I mean that we bring operational technology and IT into the same solution so they can bring in both of those skill sets. At the same time, I'm also talking about connecting the traditional shop floor with the cloud. And again, looking after best of breed and finding the optimal solution which you can use by combining the core competencies the two of them can bring. And finally, we want to make sure that we introduce new personas into the mix. Coming from manufacturing, everybody knows well that in order to build a really good machine, you have a lot of different skills you need to leverage. When it comes to a good IT solution, the same applies. And we want to show you how you can integrate these different skills from different people into a holistic solution which really touches upon the shop floor as well as the cloud. So why are we building this? Because we want to introduce transparency and connectivity into processes, into existing processes, if you look at something like a retrofit use case, or to build connectivity in from the beginning into a new line, which you would manufacturing. And we want to make things much more interchangeable and flexible. We want people to have confidence that they can update and modify the way something is being produced continuously and not just configure it once and basically keep it running as is until it reaches end of life. We want to demonstrate what data-driven manufacturing really means by showing what kind of data and information you can extract and how we would use it in a sample case which we will introduce to you later. And as I already mentioned before, a really good solution is an interdisciplinary exercise. So what we want to do is we want to show you how we can integrate different types of personas and skill sets into a manufacturing line so that ultimately the solution is stronger, it's more creative, and it has a much more diverse set of skills which are sort of making it benefit from it. So how and what are we actually talking about, right? Because I keep talking in abstract terms and I want to be making it a little bit more concrete. So what we did is, first of all, we got ourselves a bunch of industrial hardware. So we have an industrial camera, we have a proper industrial engraver, we have industrial robots, properly sealed industrial PCs. And with that, we build a demonstrator which is engraving luggage tags. So I'm talking the little things which you would attach to your suitcase, which have your name on it. And you can make sure that if a suitcase is maybe lost, it will be brought back to you because they found the identity on the luggage tag.
So how have we done this? We have real industrial hardware, so robots and an industrial engraver, and we build a production process. We have luggage tags as products that are ordered in the cloud. The orders are sent to the shop floor, and we integrated all those machines into a common layer. Additionally, obviously, we want to also show a modern process for quality control. So we included machine learning with vision to do a quality control on the raw material itself. With that, with bringing OT and IT together, with bringing machine learning and new technology in there, but with also abstracting the factory machines, we have actually an event-driven system. And not even an event-driven system, we have a hybrid event-driven system which spans the shop floor and the cloud, where the different personas can work together. Let's look how the architecture is built. On the shop floor, we need to integrate the machinery. We have an industrial PC which is running AWS IoT Greengrass. With that, we have built a standardization layer. The standardization layer is talking with different Lambda functions to the different industrial machines. So the robot as well as the engraver. So we have a common communication model and just an abstraction depending on the type of machine. Similar, we have an integration to the vision systems. We have an industrial camera which is running AWS IoT Greengrass inside the camera, and it can execute the machine learning model to do the vision inspection. The integration to the cloud is done with AWS IoT Core, which is the entry gate to AWS for devices. The structured sensor data is sent to this AWS IoT Sidewise backend, which is storing the data already in a time series database. And the images from the camera are uploaded directly to Amazon S3. If we then go to the IT systems, we see we have an ordering system which is built with AppSync. AppSync has an integration through GraphQL to DynamoDB. And the DynamoDB stream is then used to send the orders through AWS IoT Core down to the shop floor. Furthermore, we have an integration with SageMaker. SageMaker is used to pull the data out of S3 and build a machine learning model. And once the machine learning model is built, this one is sent, also triggered by AWS IoT Core, down into AWS IoT Greengrass, where the execution of the model is happening. So what we in fact have built is a small data lake, which is composed of the AWS IoT Sidewise backend, Amazon S3, as well as Amazon DynamoDB. Last step which is missing are the developers. There's an approval step which uses SAM to build the serverless application model, which is actually deployed down to the shop floor. The developers just code and change the functionality, and the automation process behind and with the approval steps is sending those changed data, those changed code down to the shop floor. What is missing in the demo are moving robots that would replenish the raw material. Well, this team is based in the US and we are based in Germany, so we used AWS RoboMaker to collaborate. We built a 3D simulation of the real-world setup where we can test the robotic movements and even integrate the service into our development workflow and CI/CD tooling. This way, developers can work independently from their own home while contributing to the greater project. With that, we have the different personas that are working actually together. We have the operators that are looking at the Sidewise monitor dashboard. We have the order managers that are using AppSync to do the orders. We have the developers that are building the code and just using what they understand best. And then we have the data scientists that are happy to build machine learning models with Amazon SageMaker.
And with this, in very few steps, we've shown you how you can dynamically integrate different personas into the process and also have all of them contribute to an overall much more holistic solution which has new capabilities helping ultimately your customers build something cool. And talking about build, finally, I would like to encourage you to actually do exactly that. Go out, build, try it out, and use our references as an example to see whether you can leverage some of the things we showcase in your own solutions. And with that, thank you very much.